November 7th, 1943. Caen-Carpiquet Airfield, northern France. Second Lieutenant William Roach peered through the thick clouds, his fuel gauge reading dangerously low. The 22-year-old pilot from the 358th Fighter Squadron had been escorting B-26 Marauder medium bombers of the 9th Air Force attacking German airfields at Montdidier and Moulins, when unexpected headwinds exceeding 100 miles per hour consumed his fuel faster than anticipated. His squadron mates had scattered in the deteriorating weather, and Roach found himself alone, desperately searching for any airfield through breaks in the overcast. This was only his third combat mission. The inexperienced pilot had been assigned to fly as a spare aircraft when another P-47, piloted by Lieutenant John Lanfear, developed mechanical problems before takeoff. Roach had joined up with Yellow Flight to complete the mission strength, escorting a force that included bombers from multiple squadrons. The mission itself had gone smoothly, but the return flight became a nightmare of navigation, uncertainty, and fuel anxiety, as the powerful headwinds pushed his consumption far beyond planned calculations. Below, he spotted a landing field through a gap in the clouds. Relief washed over him as he lowered his landing gear and brought his P-47D Thunderbolt, serial number 42-22490, nicknamed Beetle, down for an emergency landing. The massive fighter, weighing over 6 tons fully loaded, settled onto the runway with the characteristic heavy touchdown of Republic's heavyweight champion. The landing was smooth, testament to both the aircraft's forgiving handling characteristics and Roach's basic flying skill. As he taxied toward what he assumed were Allied ground crew members waving him forward, Roach felt grateful to have found sanctuary. It was only when the massive Pratt & Whitney R2800 radial engine wound down to silence and Roach slid back the canopy that the terrible truth became clear. The uniforms surrounding his aircraft bore German insignia. The ground crew were Luftwaffe personnel. The airfield he had mistaken for friendly territory was Caen-Carpiquet in occupied France. In his fuel-starved desperation, disoriented by weather and exhaustion, William Roach had delivered one of America's frontline fighters intact into enemy hands. He would spend the remainder of the war at Stalag Luft 1 as a prisoner. His aircraft would embark on a journey that would profoundly shake German confidence in their own technology. The German ground crew could hardly believe their fortune. They had watched the lone American fighter approach and land, initially assuming the pilot was wounded or the aircraft damaged. But as they surrounded the Thunderbolt, they discovered it was completely intact, fully functional, showing only normal operational wear. This was not a bullet-riddled wreck salvaged from a crash site. This was a pristine example of America's most numerous fighter, delivered as if by courier service. The Luftwaffe had been waiting for exactly this opportunity. Since P-47 Thunderbolts had begun appearing over Europe in substantial numbers in early 1943, German fighter pilots had encountered the massive American fighter with mixed reactions. Initial intelligence reports described the P-47 as heavy and cumbersome at low altitudes. American pilots themselves joked that the Thunderbolt was so large a pilot could defend himself by running around inside the fuselage. The aircraft had earned the nickname Jug. Yet combat reports noted disturbing capabilities. The P-47 carried devastating firepower from 850 caliber machine guns. It demonstrated exceptional diving speed. It showed remarkable durability, absorbing battle damage that destroyed lighter fighters. Most troubling, it demonstrated superior performance at higher altitudes, where Luftwaffe fighters had previously dominated. German pilots reported being unable to shake pursuing P-47s through diving escapes that had always worked against Spitfires. What German intelligence desperately needed was hard data from systematic testing. They needed to understand this aircraft's true capabilities and limitations. Beetle's arrival at Caen-Carpiquet provided exactly that opportunity. Within hours of Roach's capture, Luftwaffe salvage teams examined every inch of the Thunderbolt. These experienced teams immediately recognized what they had. Unlike most captured aircraft arriving with battle damage, this P-47 was pristine. Every system was intact and functional. The Germans had captured not just an aircraft, but a complete technical intelligence treasure. The immediate priority was moving Beetle away from the coast where Allied fighters routinely strafed German airfields. Luftwaffe ground crews worked through the night preparing the aircraft for its journey inland. They refueled it with captured American 100-octane aviation gasoline, performed maintenance checks, and applied temporary German markings. Within 48 hours, a Luftwaffe test pilot flew Beetle eastward toward Germany, escorted by 3 Messerschmitt Bf 109 fighters to prevent friendly fire. The formation flew at medium altitude while German anti-aircraft batteries along the route held fire, having been notified about this unusual mission. The German pilot, accustomed to nimble Messerschmitt or Focke-Wulf fighters, found the Thunderbolt's size disconcerting but also strangely reassuring. The massive aircraft felt solid and stable. The destination was Erprobungsstelle Rechlin, the Luftwaffe's primary aircraft testing and evaluation center, located approximately 100 kilometers northwest of Berlin. Established in 1916 during World War I, closed after the Treaty of Versailles, then secretly reopened in 1922, Rechlin had grown into Germany's most sophisticated aviation testing facility. By 1943, it sprawled across multiple sites, including the main turf-surfaced airfield, the satellite field at Leertz, and the waterfront facility at Rogentin on Lake Müritz. Rechlin's mission encompassed every aspect of aviation development. Germany's best test pilots flew every new Luftwaffe aircraft design through comprehensive evaluation programs. The facility employed hundreds of personnel, test pilots with thousands of hours of experience, engineers with doctorates from leading universities, and technicians trained to extract precise performance data. Rechlin's reputation rested on data quality and reliability. Test reports generated here were considered the gold standard throughout German aviation. Every major manufacturer awaited Rechlin's assessments with hope and dread, knowing favourable results could lead to lucrative contracts, while unfavourable results could doom development programs. The captured Thunderbolt's arrival in mid-November 1943 generated immediate excitement. The test staff had examined other American aircraft before, but never such an important fighter in pristine condition. This was a fully operational combat aircraft ready for immediate testing. The project received priority classification with regular progress reports required by the Reich Aviation Ministry and Luftwaffe High Command. Before test flights could begin, Rechlin's engineers needed to understand every system aboard the Thunderbolt. This proved more challenging than anticipated. The P-47 represented American design philosophy, pragmatic rather than elegant, focused on pilot survival and maintenance ease over aerodynamic purity. For German engineers accustomed to efficient packaging, the P-47's size and complexity was startling. The cockpit alone required days of study. Hans Werner Lerche, who would later become one of Rechlin's most famous test pilots, wrote extensively about his first P-47 cockpit encounter. He described it as bewildering compared to German fighters. The instrument panel seemed designed by committee, with American instruments using unfamiliar calibrations scattered across a dashboard larger than most German fighter cockpits. Every control had to be identified before flight testing could begin. The throttle quadrant alone took hours to understand, with separate levers for throttle, propeller pitch and mixture, plus additional controls for turbo supercharger regulation. The electrical system revealed sophistication that impressed German engineers. Unlike German fighters relying on hydraulics and mechanical linkages, the P-47 used electrical systems extensively. Landing gear retraction was electrical. Trim tabs were all electrically adjustable. The turbo supercharger system commanded enormous respect. German engineers had experimented with turbo supercharging for years, but never successfully implemented it in production fighters. The P-47's General Electric turbo supercharger, mounted in the rear fuselage, allowed the Pratt & Whitney R2800 engine to maintain high power at altitudes where German fighters struggled. Engineers measured duct diameters, examined turbine blade angles, studied wastegate controls, and analysed the intercooler system. The Pratt & Whitney R2800 double Wasp engine itself commanded respect. This 18-cylinder, two-row radial produced 2,000 horsepower in standard configuration. German engineers familiar with the BMW 801 radial powering the FW190 recognised similar philosophy, but the R2800 was larger, more powerful and more sophisticated. They carefully dismantled one cylinder for detailed examination, documenting sophisticated valve gear, advanced fuel injection, and the two-stage mechanical supercharger working with the turbo supercharger. The engineering sophistication impressed them, but equally impressive was manufacturing quality. Every component showed precision manufacture with consistent tolerances. This quality, routine in American production, was becoming increasingly difficult for German industry to maintain under bombing and material shortages. The armament impressed everyone. 8 Browning A&M 250 caliber machine guns represented more firepower than any German single-engine fighter. The Germans calculated that all 8 guns firing together delivered approximately 13 pounds of projectiles per second. For comparison, a Bf 109G-6 delivered less than 7 pounds per second. What struck German engineers was the installation philosophy. American designers had prioritized maintainability. Each gun could be removed and replaced in under 30 minutes. Ammunition boxes were accessed through quick-release panels. The Germans compared this to their installations, where cannon access often required removing dozens of screws. The structural analysis revealed engineering conservatism that German designers found almost extravagant. The P-47's fuselage used heavier gauge aluminum than comparable German aircraft. Everything was overbuilt by German standards, suggesting American designers prioritized structural integrity and battle damage tolerance over minimum weight. The P-47D-2 weighed approximately 10,000 pounds empty, nearly 14,000 pounds combat loaded. By comparison, a Bf 109G6 weighed 5,900 pounds empty and 7,500 pounds combat configured. The Thunderbolt weighed as much as 2 Bf-10-9s, yet flew on a single engine. After 3 weeks of ground examination, Rechlin's test pilots prepared for first flights. The captured Thunderbolt, now painted in Luftwaffe colours, sat on Rechlin's grass airfield awaiting its first German pilot. Initial test flights would focus on basic handling: takeoff, climb, level flight, simple manoeuvres, and landing. The first impression upon entering the cockpit was space. German fighter cockpits were compact and cramped. The P-47 cockpit was cavernous by comparison. The seat was wide and comfortable, adjustable in multiple directions. The canopy provided exceptional visibility. One test pilot compared it to sitting in a comfortable armchair rather than strapping on an aircraft. Starting the R2800 required following careful procedures. The massive radial coughed, backfired, then caught with a roar that shook the airframe. As the engine warmed, the pilot advanced the throttle carefully, feeling the Thunderbolt strain against its brakes. Taxiing revealed the first significant tactical advantage. The wide-track landing gear made ground handling exceptionally stable. The Bf-109's narrow gear made taxiing a constant battle. The P-47 tracked straight with minimal effort. For operations from rough fields or by less experienced pilots, this was significant. The takeoff run surprised the pilot with its length. Despite 2,000 horsepower, the Thunderbolt's weight meant leisurely acceleration. The tail came up naturally, visibility improved, and the aircraft continued accelerating. At approximately 100 miles per hour, the pilot eased back and the Thunderbolt lifted off smoothly. The initial climb was where German expectations collided with uncomfortable reality. Pre-flight calculations suggested mediocre climb performance. The actual performance was better than predicted. More disturbing, as altitude increased, The Thunderbolt's climb rate remained strong far longer than anticipated. At 5,000 feet, the Bf-109G6 climbed at approximately 3,900 feet per minute versus the P-47's 2,750 feet per minute. At 10,000 feet, the Bf-109 managed 3,600 feet per minute versus 2,700 feet per minute. The German fighter was clearly superior, as expected. But at 20,000 feet, something disturbing happened. The Bf-109's climb rate degraded to 2,200 feet per minute, while the P-47 maintained 2,600 feet per minute. At 25,000 feet, the P-47 climbed at 2,400 feet per minute, while the Bf-109 managed only 1,600 feet per minute. This high-altitude performance confirmed combat reports. The turbo supercharger provided decisive advantage that fundamentally altered combat dynamics. German fighters could no longer count on high-altitude sanctuary. The traditional tactic of climbing above enemy formations was neutralized when the enemy could climb higher with better performance. Level flight testing produced similarly sobering results. At sea level, the P-47 achieved approximately 352 miles per hour, respectable but not extraordinary. German fighters were competitive. But at 25,000 feet, the P-47 reached 427 miles per hour. At 30,000 feet, where American heavy bombers operated, the Thunderbolt achieved 433 miles per hour. German fighters struggled to exceed 380 miles per hour at similar altitudes, a deficit of over 50 miles per hour that translated to tactical disaster. The diving performance exceeded every expectation. One test pilot put the Thunderbolt into a 30-degree dive from 25,000 feet. The aircraft accelerated smoothly. At 20,000 feet, the airspeed showed 450 miles per hour. At 15,000 feet, 500 miles per hour. At 10,000 feet, over 550 miles per hour. The pilot began recovery, noting heavy but effective control forces. The P-47 transitioned smoothly to level flight. German fighters could dive quickly, but not this quickly, and certainly not with this combination of control and structural safety. The Bf-109's wing generated compressibility effects, making recovery difficult. The FW-190 was better, but still developed control heaviness. The Thunderbolt could dive with near impunity. German fighters could no longer safely disengage by diving away, a fundamental tactic that had saved countless German pilots' lives. Maneuverability testing revealed expected trade-offs. The P-47's weight meant it couldn't turn with lighter German fighters in sustained combat. But the test pilots noted the P-47's exceptional roll rate. At speeds above 250 miles per hour, where most combat occurred, the Thunderbolt could reverse direction through rapid rolls faster than a German fighter could turn. While it couldn't sustain turns, it could maneuver effectively using different techniques. Maximum altitude testing produced perhaps the most troubling results. Test pilots climbed systematically. At 40,000 feet, the Thunderbolt remained responsive with adequate power. At 42,000 feet, the aircraft could clearly operate even higher. The test report noted combat capability at 40,000 feet exceeded what German fighters achieved at 35,000 feet. German fighters struggled to reach 38,000 feet, with virtually no combat capability at such altitudes. The P-47 operated comfortably at 40,000 feet with enough performance for combat. American bombers typically flew at 25,000 to 28,000 feet. The P-47 could escort them while operating 12,000 to 15,000 feet above, giving enormous tactical advantage. Armament testing demonstrated devastating firepower. The 8 guns cycled smoothly with impressive volume of fire. A 1-second burst put approximately 80 rounds into the target area. What impressed German observers was ammunition capacity. With 3,400 rounds total, the P-47 could fire for 30 seconds. German cannon fighters carried perhaps 200 rounds, requiring strict fire discipline. Durability testing confirmed incredible combat reports. The structural analysis explained resilience. The massive radial engine provided protective shielding. The aircraft's size meant separated and often duplicated vital systems. One test simulated battle damage. The P-47 could lose significant tail surfaces and remain controllable. It could sustain multiple cylinder damage and still fly. It could absorb wing damage that would destroy a Bf-109. The systems analysis revealed manufacturing sophistication Germany could no longer match. Every component showed precision manufacture and quality materials. Bearings were precision ground to tighter tolerances. Every fastener was correctly sized and specified. The aircraft showed no manufacturing shortcuts or substitute materials. This suggested capabilities that German engineers found sobering. The P-47 was complex to build. Yet Republic Aviation and Curtiss-Wright were producing these aircraft at rates exceeding 50 per month at each factory by late 1943. The maintenance examination produced troubling conclusions. German fighters required extensive maintenance by skilled mechanics. The P-47 was engineered for sustained operations with minimal maintenance. The radial engine was accessible with easily opened cowling panels. All maintenance points were clearly marked and easily reached. The entire philosophy prioritized operational availability. After 6 weeks of intensive testing, Rechlin produced a comprehensive evaluation report. The document was classified Geheime Kommandosache, distributed only to senior commanders. The assessment was blunt. The P-47 Thunderbolt represented a significant threat that current Luftwaffe tactics and aircraft were inadequately prepared to counter, especially above 20,000 feet. The report identified grave concerns. The P-47's high-altitude superiority meant American fighters could choose when and where to engage. Its diving speed meant German fighters couldn't safely disengage. Its durability meant successful attacks often failed to achieve kills. Its firepower meant any aircraft caught in its sights faced near certain destruction. Its range with drop tanks meant no German target was safe from escort. The report recommended urgent development of German fighters capable of matching high-altitude performance, though authors knew this would take years Germany didn't have. It recommended revising tactics, avoiding high-altitude combat, attacking only from overwhelming advantage, using hit-and-run tactics. It recommended everything except the one thing Germany needed: time. The captured Thunderbolt, after completing its Rechlin test program, was assigned to the Circus Rosarius, commanded by Flugkapitän Theodor Rosarius, and designated as part of the second Staffel of the Versuchsverband Oberbefehlshaber der Luftwaffe. The Circus Rosarius had a vital mission: familiarizing frontline Luftwaffe pilots with captured Allied aircraft through hands-on demonstrations. The unit operated like a traveling air show with deadly serious purpose. It would arrive at fighter bases with captured aircraft including Spitfires, P-51 Mustangs, P-38 Lightnings, and P-47 Thunderbolts, all repainted in German colours bearing the distinctive T9 identification code. Experienced test pilots would fly these aircraft through choreographed demonstrations showing capabilities and limitations. Frontline pilots attended briefings with performance data and tactical recommendations. Selected pilots sometimes flew captured aircraft under supervision. This practical education was designed to save German pilots' lives. The Circus's P-47, repainted in standard Luftwaffe camouflage with bright yellow markings identifying it as a test aircraft, bore the code T9+FK. The yellow markings prevented friendly fire from German anti-aircraft units and made the aircraft highly visible during demonstrations. When the Circus arrived at bases across Germany and occupied territories throughout 1944, the P-47 drew crowds. Pilots who had encountered Thunderbolts studied it carefully. Maintenance personnel examined the accessible engine and well-designed panels. Younger pilots received education that might save their lives. Demonstration flights were carefully choreographed. A test pilot would start the engine, taxi demonstrating excellent ground handling, then take off. German fighters would orbit overhead. The P-47 would climb to 25,000, then 30,000 feet, maintaining rates German fighters struggled to match. At altitude, it would accelerate effortlessly. Then came the dive demonstration. The Thunderbolt would dive from 30,000 feet with a Bf-109 attempting to follow. Initially descending together, the P-47 would pull steadily away. The demonstration made undeniable. You cannot escape a P-47 by diving. Then came the turning demonstration. At lower altitude, the P-47 would engage a Bf-109 or FW-190. The German fighter would clearly outturn the American fighter. This showed German pilots they still had advantages, that proper tactics could defeat the P-47. Briefings emphasized specific tactics based on Rechlin testing. Avoid high-altitude combat above 20,000 feet. Avoid diving as escape. Exploit poor turning performance through sustained turning combat at lower speeds. Attack from below where the engine limited visibility. Engage only with energy advantage. Make high-speed slashing attacks rather than sustained combat. Walter Wolfram, a Luftwaffe pilot with over 130 victories, flew captured P-47s. His recollections captured common German response. During the war, I had opportunity to fly captured P-47s. I didn't like the Thunderbolt. It was too big. The cockpit was immense and unfamiliar. Wolfram's reaction reflected training in nimble German fighters, but he also recognized what the P-47 represented, a philosophical approach prioritizing pilot survival, durability, and producibility over performance elegance. The Circus's educational mission became increasingly urgent as Allied production overwhelmed Luftwaffe capabilities. By mid-1944, the unit's inventory included multiple P-47s, several P-51 Mustangs, P-38 Lightnings, captured Spitfires, and even a Hawker Typhoon. But the gap between understanding enemy capabilities and possessing competitive German aircraft grew wider. German pilots knew how to fight P-47s optimally. They lacked sufficient competitive fighters to implement tactics consistently. They knew they should avoid high-altitude combat, but American bombers flew high, forcing German interceptors to climb where P-47 escorts dominated. By late 1944, maintaining captured aircraft became a logistical nightmare. P-47S required American 100-octane fuel, increasingly scarce. They needed spare parts that could only be salvaged or fabricated. Engines required specialized maintenance. German mechanics struggled to provide without proper manuals or tools. By April 1945, with Allied armies advancing and Germany collapsing, the Circus Rosarius effectively ceased operations. Its aircraft were scattered across airfields. Some were destroyed to prevent recapture. Others were abandoned. A few were discovered intact by advancing Allied troops. One captured Thunderbolt ended up at Bad Wörishofen in southern Germany, discovered by American forces in May 1945. American intelligence officers were surprised to find their own fighter, carefully maintained in immaculate German camouflage, bearing evidence of extensive testing. The aircraft was documented and photographed before being scrapped. Throughout 1944, multiple navigation errors by Allied pilots resulted in several P-47s falling into German hands. The pattern was tragically consistent. Allied pilots low on fuel, disoriented in weather or after combat, spotting what appeared to be friendly airfields, landing with relief, then discovering too late their terrible mistake. Each captured aircraft allowed German intelligence to track American production improvements. They noted propeller installation changes, cockpit layout improvements, the introduction of water methanol injection systems, and the evolution from razorback to bubble canopies. Every detail was carefully documented and reported, but all this intelligence gathering, meticulous testing, and pilot training could not change fundamental realities. The aircraft was physical evidence of capabilities that Germany could not match. Every system examined spoke of a nation with vast resources, advanced technology, skilled workers, and seemingly unlimited production. The Germans calculated production rates through intelligence reports and interrogation of captured airmen. Republic Aviation's Farmingdale facility was producing approximately 60 P-47s per month by mid-1944. Curtiss Wright's Buffalo facility added another 55 per month. Combined production exceeded 115 aircraft monthly from just 2 factories building a single fighter type. Total American fighter production in 1944 exceeded 38,000 aircraft. Germany managed approximately 25,000 fighters in the same year, despite mobilizing every resource. The Americans were producing more fighters while fighting on multiple fronts, supplying allies, and maintaining massive strategic bombing campaigns. Even if German pilots achieved favorable kill ratios through perfect tactics, it wouldn't change outcomes. The Americans would simply produce more aircraft and train more pilots. German pilot training had shrunk to barely 50 hours total by late 1944, compared to over 200 hours for American pilots. This training disparity, combined with numerical inferiority and performance gaps at critical altitudes, created conditions where German fighter forces faced systematic defeat. The high-altitude performance that Rechlin quantified manifested in strategic disaster throughout 1944 and into 1945. American heavy bombers flew at altitudes where P-47 escorts protected them effectively, while German interceptors struggled. The Thunderbolt's ability to maintain combat capability at extreme altitudes meant escort fighters could position above German interceptors with decisive advantage. German efforts to develop competitive high-altitude fighters produced aircraft that arrived too late. The Focke-Wulf TAR-152 could exceed the Thunderbolt's altitude capability, but only a handful were built. The Messerschmitt Bf-109K incorporated improvements that narrowed the performance gap, but it appeared too late to matter. The jet-powered Messerschmitt Me 262 represented German technological prowess at its peak. But the program was plagued by engine reliability problems, fuel shortages, and Hitler's insistence it be developed as a bomber. By the time substantial numbers entered service, Germany lacked the fuel, trained pilots, airfield infrastructure, and time to employ them effectively. Combat reports throughout 1944 and into 1945 showed tactical evolution based on Rechlin testing and Circus training. Pilots reported successful engagements where recommended tactics defeated P-47s. These successes demonstrated that properly flown German fighters could compete under specific circumstances. But these tactical victories were isolated successes against overwhelming odds. For every successful engagement, there were dozens where Allied numbers, superior positioning, mechanical failures, or exhaustion resulted in German losses. The Luftwaffe was fighting an attrition war it couldn't win. Every experienced German pilot lost was nearly irreplaceable. Every P-47 shot down was replaced within days. The asymmetry was unsustainable. The Thunderbolt's ground attack capability devastated German ground forces throughout 1944 and 1945. The P-47 could carry 2,000 pounds of bombs or 10 rockets, then strafe with 8 machine guns. The combination of armour protection, powerful armament, and rugged radial engine made it extraordinarily effective for low-altitude attack work. German ground forces learned to dread Thunderbolt formations. From D-Day through the war's end, P-47s flew close air support missions that directly contributed to Allied success. They destroyed German armour attempting to counterattack in Normandy. They obliterated supply columns. They demolished railway infrastructure. They attacked airfields. The scale was unprecedented, with pilots claiming destruction of tens of thousands of railway cars, locomotives, armoured vehicles, and trucks. The strategic bombing campaign that devastated German industry, disrupted transportation, destroyed synthetic fuel production, and broke German economic capacity was enabled by fighter escorts, The P-47, along with the P-51 and P-38, made strategic bombing viable by winning air superiority over Germany itself. The psychological impact extended beyond technical assessments to affect morale. German pilots who had begun the war with absolute confidence faced enemies flying aircraft that embodied seemingly unlimited resources. Every captured Thunderbolt revealed quality manufacture. Every encounter showed American pilots attacking aggressively. Every mission revealed more Allied fighters. Heinz Baer, a Luftwaffe ace credited with 220 victories, commented that the P-47 could absorb an astounding amount of lead and had to be handled very carefully. This assessment from one of Germany's most successful pilots revealed fundamental shifts in tactical thinking. By 1943 and 1944, German pilots handled Allied fighters carefully, knowing mistakes would be fatal, and even successful attacks might not achieve kills against aircraft as durable as the Thunderbolt. German tactics included attacking P-47 formations before drop tanks could be jettisoned, aiming for belly-mounted external fuel tanks, engaging at lower altitudes to minimize turbo-supercharger advantage, and using hit-and-run attacks. These tactics sometimes worked under favorable conditions, but they required German fighters to achieve advantageous positioning, which became increasingly difficult as American numerical superiority grew and American pilots gained experience. One fascinating aspect of the captured P-47 program was the interaction between German and American design philosophies. German fighters emphasized lightweight construction, aerodynamic efficiency, and high specific performance. American fighters emphasized ruggedness, firepower, and operational practicality. Neither approach was objectively superior. Each reflected different circumstances and requirements. Germany needed fighters manufactured quickly with minimum materials, maximizing performance per unit weight, operating from rough fields with minimal support. The Bf-109 embodied these requirements brilliantly, achieving excellent performance from a compact airframe. But this efficiency came at costs: structural fragility, maintenance difficulty, limited range, and combat vulnerability when damaged. America could afford to build fighters weighing twice as much, using generous safety factors, incorporating redundant systems, and prioritizing pilot survival. The P-47 embodied this philosophy completely. It was over-engineered by German standards, heavy and complex, but it kept pilots alive, remained operational despite damage, delivered devastating firepower, and could be maintained by personnel with basic training. The test pilots at Rechlin understood these philosophical differences. They noted that if Germany could produce P-47s in quantity with assured fuel and spare parts, the Luftwaffe would adopt them despite their weight. But Germany couldn't produce such aircraft given its circumstances. German industry struggled to build simpler Bf-19s and FW-19s0S. One particularly revealing analysis compared man-hours required to build aircraft. The Bf-109 required approximately 4,000 man-hours, representing German efficiency at its peak. Rechlin engineers estimated the P-47 required 10,000 to 12,000 man-hours, 3 times the effort. Yet American factories were producing P-47s faster than German factories produced Bf-109s. The spare parts situation provided another measure. American combat units received pre-packaged maintenance kits for various intervals. More extensive parts were available through logistics chains that could deliver almost anything within days. German units scrounged parts from wrecked aircraft, waited weeks or months for critical components, and often cannibalized aircraft to keep others flying. The pilot training disparity was another critical factor. German test pilots estimated training a pilot to operational proficiency in the P-47 would require 40 to 50 hours, specifically in type. American pilot training programs provided 200 to 250 hours total before pilots joined operational units. Germany was sending pilots to frontline units with 30 to 50 hours total by late 1944. These barely trained pilots faced American opponents with 5 times more experience, flying superior aircraft in greater numbers. One test report written in early 1944 included a remarkably candid assessment. The P-47 Thunderbolt represents American industrial might applied to fighter aircraft design without the constraints we face. Its performance, while not superior to German fighters in all aspects, is adequate in all aspects, and superior in those most important to strategic warfare: high-altitude performance, durability, range, and firepower. More significantly, it can be produced in quantities that make individual aircraft quality almost irrelevant to strategic outcomes. We face an enemy who can afford to build fighters weighing twice what ours weigh, using twice the strategic materials, requiring 3 times the manufacturing effort, and still produce them faster than we can destroy them. This is not a technical problem with a technical solution. Combat statistics confirmed what test data predicted. In 1944, the P-47 flew over 546,000 combat sorties. Approximately 3,500 were lost to all causes, including anti-aircraft fire, mechanical failures, weather accidents, and air-to-air losses. This represented a loss rate of barely 0.7% per sortie, remarkably low for intense combat. By comparison, Luftwaffe fighter loss rates exceeded 2% per sortie, nearly triple the Thunderbolt's rate. The P-47's combat record included 3,752 confirmed aerial victories against Luftwaffe aircraft, with additional thousands destroyed on the ground. 7 of the top 10 American fighter aces in the European theatre flew P-47s during at least part of their careers. The aircraft proved effective in every assigned role: high-altitude bomber escort, air superiority fighter, fighter bomber, ground attack, and close air support. Its versatility reflected engineering margin built into the design. German fighters were typically optimized for specific roles. The P-47 could perform all roles adequately with minimal modification, demonstrating the value of robust design over specialized optimization. Pilot survival rates told another crucial story. P-47 pilots often weren't shot down at all despite battle damage that would have doomed lighter fighters. This asymmetry in survival compounded through years of combat, preserving experienced American pilots, while German pilot ranks were systematically attrited. By late 1944, the average experience of American fighter pilots vastly exceeded their German opponents. By early 1945, when captured, Thunderbolts were grounded by fuel shortages and operational impossibility. They had served German intelligence well within inherent limitations. They had provided accurate performance data. They had enabled tactical development. They had trained hundreds of pilots. But they had also provided uncomfortable education about American capabilities that Germany couldn't counter. The end came in Germany's final collapse during spring 1945. Allied armies overran airfields where captured P-47s sat abandoned or hastily destroyed. American intelligence officers found these aircraft with mixed feelings: satisfaction at recovery, curiosity about what Germans learned, and awareness that this knowledge had ultimately mattered little in determining the war's outcome. Hans Werner Lersche, the Rechlin test pilot who flew many captured Allied aircraft, survived the war. He surrendered to American forces and cooperated with Allied intelligence officers interested in German evaluation procedures. By the early 1950s, Lersche had immigrated to the United States, finding employment in the aerospace industry. His experience proved valuable to American companies developing new technologies. In the 1970s, he published memoirs providing historians with invaluable first-hand accounts. Lersche's writings about the P-47 were notable for technical precision and candor. He described strengths and weaknesses without propaganda distortions. His respect for the Thunderbolt's engineering was evident, as was his recognition that it represented capabilities Germany could not match. He noted particularly the spacious cockpit, robust systems, structural strength, and power available at all altitudes. He also noted that his experiences testing Allied aircraft contributed to understanding how thoroughly German propaganda had misled both military personnel and civilians about Allied technological capabilities. The aircraft he flew demonstrated conclusively that Allied designs were sophisticated machines reflecting valid philosophies appropriate for the type of war being fought. Other German pilots and engineers who tested captured P-47s went on to various post-war careers. Some found employment in the revived German aviation industry of the 1950s. Others emigrated to countries where German expertise was welcomed. Several former Rechlin test pilots provided interviews to historians in later decades, ensuring the story would survive beyond official reports captured in 1945. Their assessments were remarkably consistent. The P-47 was formidable. German fighters could defeat it under specific circumstances, but it represented advantages Germany couldn't overcome through tactical excellence alone. Walter Wolfram survived the war with over 130 victories and continued flying in the post-war era. He worked as a commercial pilot and instructor. In interviews during the 1980s and 1990s, he spoke candidly about his wartime experiences. His assessment remained consistent. He hadn't liked flying the P-47 because it felt wrong to a pilot trained on nimble German fighters, but he respected what it represented. Theodor Rosarius, commander of the Circus Rosarius, also survived. His organization had trained thousands of pilots in Allied fighter capabilities, potentially saving lives through education. The Circus's mission had been crucial as Allied numerical superiority grew. German pilots who had been exposed to captured aircraft through the Circus program showed slightly better survival rates and marginally better combat effectiveness, perhaps 10 to 15% improvement reflecting better understanding of enemy capabilities. However, these modest improvements at the individual level could not overcome systematic disadvantages German fighter forces faced. Second Lieutenant William Roach spent the war's remainder as a prisoner at Stalag Luftwaffe, liberated by Soviet forces in late April 1945. He returned to the United States shortly afterward. Like many veterans, Roach rarely spoke about his wartime experiences. His capture on his third mission may have been something he preferred not to dwell on. He lived quietly after the war. Production statistics reveal the magnitude of American achievement. Republic Aviation and Curtiss Wright produced 15,683 P-47 Thunderbolts between 1941 and 1945, making it the most produced American fighter. Production ramped from dozens per month in early 1942 to peak rates exceeding 140 monthly by late 1944. Germany produced approximately 34,000 Bf-109s of all variants from 1939 to 1945, averaging about 5,600 yearly. FW-190 production totaled approximately 20,000 aircraft from 1941 to 1945, averaging 4,000 yearly. American production of just the P-47 approached 20% of total German fighter production, while also producing numerous other types. The German captured aircraft program tested dozens of Allied types during the war. The exact number of P-47s captured intact enough for flight testing remains uncertain, but at least 3 are well documented. Several additional P-47s were captured too damaged for flight, but useful for technical examination. No captured P-47 bearing German markings is known to have survived to the present day, though photographs and documents preserve their story. The broader impact of P-47 operations and intelligence gained from captured examples extended beyond immediate tactical considerations to influence post-war aviation development in multiple nations. American designers learned from the program both what worked and what could be improved. The aircraft's durability and firepower clearly succeeded and influenced subsequent designs. Its weight and size, while accepted during wartime, seemed excessive for peacetime, influencing trends toward more efficient designs in the early jet age. German designers who examined captured P-47s and survived took lessons about turbo supercharging, structural design, systems integration, and manufacturing into their post-war careers. Recognition that durability and maintainability were as important as peak performance influenced post-war German aviation philosophy. The captured P-47 program demonstrated both the value and limitations of technical intelligence in modern warfare. The Germans gained accurate, detailed knowledge through systematic testing and practical training. This knowledge was valuable and potentially saved lives. German tactics evolved based on this intelligence, showing measurable improvements when properly implemented. However, technical knowledge could not overcome strategic-level disadvantages. Germany knew exactly what the P-47 could do, understood its strengths and weaknesses, and developed appropriate countermeasures. But Germany lacked sufficient competitive aircraft, adequate fuel supplies, enough trained pilots, and ultimately the time to develop and deploy aircraft matching American high-altitude performance. The story of Luftwaffe pilots testing the captured P-47 Thunderbolt demonstrates the relationship between tactical excellence and strategic resources in industrial-age total war. Professional competence, technical expertise, and tactical innovation, while necessary and valuable, cannot overcome fundamental disadvantages when fighting a protracted war of attrition against numerically superior enemies with vastly greater resources. The test pilots at Rechlin approached their evaluation with professional integrity, setting aside propaganda to produce accurate assessments. They documented capabilities honestly, acknowledged strengths clearly, identified weaknesses precisely, and developed tactical recommendations that gave German pilots their best chance of surviving encounters with Thunderbolts. But professional excellence in tactical intelligence could not change the strategic equation. Every system examined spoke of abundant resources, advanced manufacturing, skilled workers, and production operating at levels Germany couldn't approach. The aircraft was physical evidence that Germany faced enemies who could afford to build fighters weighing twice as much, using twice the materials, and still produce them faster than Germany could manufacture simpler designs. The captured Thunderbolt was simultaneously one of Germany's greatest intelligence successes and a harbinger of inevitable defeat. It demonstrated through its very existence the industrial might that would overwhelm German resistance regardless of tactical skill. Second Lieutenant William Roach's navigation error on November 7, 1943, inadvertently provided German intelligence with one of its most valuable technical coups. The pristine P-47 he delivered allowed systematic testing that removed uncertainty about American fighter capabilities. But it also provided uncomfortable clarity about the magnitude of the challenge Germany faced. The lesson was thorough, the teaching professional, and the intelligence accurate. But the strategic reality revealed was unchangeable by any actions Germany could take in its circumstances of 1943 to 1945. The knowledge gained was valuable, the intelligence work professional, and the tactical responses appropriate. Yet the strategic lesson embedded in every component of that massive fighter was clear. Germany faced enemies who could afford to build such aircraft in overwhelming numbers, and tactical skill alone could not overcome that fundamental advantage.